Good morning. My name is Bob Muro from Wireless Telecom Group. I'm the Applications Manager, and today's demo relates to satellites as we're here at the Satellite Show. So we have one of our UFX models, which is a noise generator, and a place where you can have the noise added to the path. And we were graciously lent from DBM a satellite link emulator. We have our standard selection of USB power meters with their base stations. And we also have one of our Holsworth phase noise analyzers. So today's stimulating signal is going to be coming from our 6 gigahertz 6001B module from Holsworth. It's going to go into a sensor to be measured. So we have input and output power measurements. It will go through the multipath fading emulator, come out, we can add some noise to it, and then we're going to look at the response on our Holsworth phase noise analyzer. The point to this is just the versatility and the things that you can do with the multiple pieces of equipment that we have available. So one of the things that we noticed, we have an output here, and I will highlight this. So this module has a very clean, very low phase noise output. So you see it from -80 in close to from 10 hertz all the way out to 100 megahertz. And what we wanted to do was to add multiple paths and see what the various phase noise changes would occur. So as we add the entire system, which includes couplers, the fading path emulator, our noise source itself, you could basically see that we've got a lot more additive phase noise. Now this is technically not the way that you do a 2-port method, but it's a nice way to kind of look at your system. And what we'll do now is we'll take an additional measurement because we're going to add white noise to the final product of the system, and you'll basically see as we acquire, we're doing 10 correlation sweeps. It'll take a few seconds, basically about 10 or 12 seconds, and what's going to happen is you're going to see we've added white noise, and we're going to increase the amount of jitter, which could possibly happen in your system. And there we have it. So now we've increased from about 400 femtoseconds to about 580 femtoseconds. So for anybody doing very precise oscillator measurements or using synthesizers, you might want to see what's going to happen when you increase the size of your system and add or subtract different parts. And that's essentially what we're doing today here at Satellite.